Greetings one and all. My name is Soujanya Ambala. Now I would like to give a demo on functional dependencies in database management system. Now what is a functional dependency means? For example, if you take any table or any relation, it consists of attributes, right? So one attribute is depending on another attribute. How we'll come to know means using this functional dependency, we will understand. For example, take student ID. Based on the student ID, we can determine student name. Now, this student ID determines student name is called as a functional dependency. This student ID is called as determinant. Student name is called as dependent. Why it is called as dependent means student name is depending on the student ID. So this is called as a functional dependency. Now, why we are learning this functional dependency means it is helpful in analyzing the relation. Let's take any big application. It consists of large data. Here, if there is no proper functional dependency idea, we can't understand the complete database design. So if we write the functional dependencies in this way, we can understand which attribute is related to which attribute and which attribute is a primary key. All those things we can understand using these functional dependencies. And these functional dependencies very helpful in normalization, and it is also helpful in data redundancy, data integration. All those things are helpful using this functional dependency. Now let's see here. It is helpful in redundancy. Redundancy means duplicate data. If a table consists of duplicate data, by seeing the functional dependencies, we can understand the data is repeated more than one time. So it is not allowed in database design. We have to remove the duplicate data, and it is helpful in insertion, updation, deletion anomalies. Let's see the insertion anomalies. Let's look at this table. It consists of rows and columns. This is student ID. It is 1 and 2 value, names X, Y, some ages 30 and 20 years. Let's assume like this. Now we are focusing on insertion anomalies. In this table, for example, I want to update roll number or the student ID 1, age by mistakenly it entered as 30. I want to change it to 18. I want to change it to 18. In this case, if I do any operations, it works well and good because there is no duplication of data. Let's assume one more row is there with name X and age is 40 but different roll number ID. Now based on the name, if I want to update, for example, wherever name equals to X, I want to change age to 18. In this case, it will update in the first row and in the third row itself because wherever the name is X, their age value will update. It is not at all a correct way to insert because of this repetition of data, means redundant data. When we are performing insertions, it gives the different results. So it gives insertion anomalies. In order to overcome from this problem, we are removing the redundant storage. How we can implement this redundant storage means by using proper normalization forms, we can reduce the redundant data or else we can remove the duplicate data. Now the same concept will apply for deletion and updation also. Whenever the data is duplicate, means repeated data is there on the relation, when you perform any of these DML operations, it gives data inconsistency. Now the definition of functional dependency means it can be used to identify the schemas, and we can understand the problems in the given database by seeing this functional dependencies. And it is helpful in decomposing also. Means, for example, if there is any big database is there, it consists of so many tables. It consists of so many lines, and when you want to analyze the data, it is difficult. So in order to understand the database design, we need to decompose into smaller relations. We can achieve this decomposition using these functional dependencies. Now let's see. X tends to Y. Here X is one attribute, Y is one attribute. X is called as determinant, Y is called as dependent. Y attribute is depending on the X attribute. It means let's take employee ID. employee name. For example, employee ID is 21, the name is John, something like that. So this name is depending on this ID. Whenever ID varies, name will change. Let's take the employee ID is 30, the name will change to Bob, something like this. It means that this employee name is called as dependent, employee ID is called as determinant. Now, we have different types of functional dependencies. One is trivial functional dependencies, another one is non-trivial functional dependencies. Trivial functional dependency means if you take any functional dependency extends to y, y is a subset of x, then it is called as a trivial functional dependency. Let's take a set of attributes x and y. X consists of ID, name, determinant set of attributes. Y consists of name. In this case, y is a subset of x, means the right side of the determinant, whatever the attributes are there, they should be the subset of left side of that functional dependency, means x. In this case, we can write like this. It is a subset of name. Like this. It is called as a trivial functional dependency. Coming to non-trivial functional dependency means where y is not subset of x, vice versa. Here, if you write x tends to y, x is determinant, y is dependent. Here it is only ID, but where dependents are more, name, age, salary, something like this. Where the dependent attributes are more than this determinant, it is called as a non-trivial functional dependency. Now, why we are learning this functional dependency means, let's take any table. ID, name, department. Let's assume like this. ID is 1, 2, 3, name A, B, C, department IT. Let's assume. In this case, this functional dependency clearly states that where T1 of x equals to T2 of x, if this exists, obviously T1 of y is equals to T2 of y should possible. Means if you take this functional dependency x determines y, in this case, x is nothing but an attribute. In our scenario, ID. Y means name. Y attribute is name. So name is depending on the ID attribute. It means when T1 of x means in the tuple 1, whatever the x value equals to, if in the tuple 2 x value, when this exists, the dependence also should match. It means if we have one more row with same values, where T1 of x equals to T2 of x, T1 means tuple 1, tuple means row. In the row 1, whatever the x value, if it is equals to in the row to x value, there should be a possibility that in T1, the dependent value should match. Then only we can say that x determines y existed. Here you can see T1 of x equals to T2 of x means 1 equals to 1. Let's check T1 of y equals to T2 of y. Here T1 means tuple 1. In the tuple 1, y attribute is name. In the tuple 1, y attribute value is A, where ID equals to 1. In the tuple 2, name value is also y. So when T1 of x equals to T2 of x exists, it must exist T1 of y is equals to T2 of y. And we can also say that it is a functional dependency from x to y, or we can say it as y is functionally dependent on x. We can call two ways. Whenever you write this functional dependency, you can say it as x determines y, or y is functionally dependent on x. Now let's see one more thing. If you have a workers relation, means worker table, it consists of columns like SSN, name, LOT, department ID, etc. Since these are the different column names. In this case, how we will analyze the functional dependency means based on the SSN social security number, I can extract the department ID. In the same time, if you know the department ID, you can get this attribute value. Finally, you can say this using this SSN, you can get this attribute. This is called as a trivial functional dependency. In the maths, we learned that X tends to Y tends to Z. If it is there, you can say X tends to Z is possible. The same logic applies here. X and Y are nothing but here attribute. If there is any functional dependency in this manner, it is called as a trivial functional dependency. It is existed. For example, using ID, if you are able to extract the name, and second functional dependency, using name, if you are able to extract the GPA of the student. In this case, you can directly, third functional dependency you can form as using ID, you can extract the GPA of the student. Now, next topic is closure of a functional dependency. If we have any functional dependency, how we will find the closure of that functional dependency? Closure is nothing but based on the closure, we will come to know how many attributes are depending on that particular attribute. Now, if you take closure of a set of functional dependencies, these are the rules which we have to follow: reflexivity, augmentation, and transitivity. Now, let's find the closure of set of attributes. This is the example. On this relation, now we are going to find out the closure. Here the functional dependencies are A determines B, C determines D, A determines D. Some random functional dependencies. Now, how we need to find the closure means, we will write in a braces like this. It means we are finding the closure of attribute A. Whenever you find the closure of any attribute, the first thing is you have to write that attribute itself, right? Then write the dependent attributes which is depending on the A attribute. After writing A, you can write B and D here. B comma D. This is the way to find out the closure of an attribute. Now you may get the doubt, what is the need of finding the closure of this attribute? It clearly states that based on the A attribute value, the dependence B and D values will change. So whenever you want to update any changes, we have to be very careful that in the big database design, if you change this attribute, the dependence values will change. It clearly states that. In the same way, you can find out the closure of attributes for all the attributes. And let's take B attribute. In this case, whenever you're finding the closure of attribute B, here we don't have any functional dependency like this. Some B tends to some E. This functional dependency is not available. See, B tends to is not there. In this case, whenever you want to write the closure of that attribute, only that attribute will come. That's it. Because there is no functional dependency depending on this B attribute. Clear? Thank you.